Welcome to Global Site Engineering, real experience. In today's video, we'll explore a fundamental topic in industrial construction and engineering: what is piping? Piping is an interconnected system of pipes, fittings, valves, flanges, and other components designed to transport fluids such as water, steam, oil, gas, or chemicals under controlled pressure and temperature conditions. This system is not just a few pipes, it's a permanent, engineered network that is governed by international standards like ASME, ASTM, API, and ISO. Let's start with the basics. Difference between pipe and piping. A pipe is a single cylindrical tube, for example, an ASTM A106 grade B carbon steel pipe. But a piping system includes everything: pipes, valves, fittings, gaskets, supports, and insulation, designed for safe and efficient fluid handling. Codes like ASME B31.3 and B31.1 govern how these systems are designed, fabricated, and inspected. Now let's look at the key components of a piping system. Pipe. It's the main channel through which the fluid flows. Materials like A106 grade B or stainless steel 316 are commonly used. Fittings. These include elbows, T's, and reducers, used to change the direction, branch, or size of the piping. Valves. Valves control the flow. They can start, stop, or regulate the fluid. Common types include gate, globe, ball, and check valves. Flanges and gaskets. Flanges join two pipe sections, while gaskets provide a leak-tight seal. Supports. Pipe supports and hangers ensure that pipes are safely held in position. Insulation. Used to prevent heat loss or protect personnel from hot surfaces. Instrumentation. Devices like pressure gauges, flow meters, and temperature sensors provide critical process data. Let's now discuss different types of piping systems based on application. Process piping, found in refineries and petrochemical plants. It handles hazardous or chemical fluids under pressure. Power piping, used in power plants to carry high-pressure steam. Utility piping, supplies air, nitrogen, water, and steam throughout facilities. HVAC piping, for heating, ventilation, and air conditioning. Plumbing piping, found in buildings for water supply and waste removal. Slurry piping, used in mining industries to carry liquid and solid mixtures. Now let's talk about materials used in piping systems. Carbon steel, like A106 and A105, used for general services such as water, steam, and oil. Stainless steel, SS304 and SS316 are corrosion resistant and used in chemical, food, and pharmaceutical industries. Alloy steel, P11, P22, and P91, designed for high temperature and pressure conditions. Plastic, PVC, CPVC, and HDPE are used in low pressure and chemical lines. Copper and brass, typically used in HVAC and plumbing systems. Let's move to piping standards and codes. ASME B31.3 governs process piping in industries. ASME B31.1 power piping used in thermal and power plants. API 5L used for lined pipe in oil and gas pipelines. ASTM standards, like A106, A234, define material grades and specs. ISO 9001 ensures quality management. Nathemister 0175 defines material selection in corrosive, sour environments. Now let's understand pipe size terminology. NPS, nominal pipe size, measured in inches. DN, diameter nominal, the metric version of NPS. Schedule, refers to the wall thickness. For example, Schedule 40 or Schedule 80. Odd and ID, outside diameter and inside diameter, which affect flow rate and strength. Why is piping so critical in industry? It maintains the flow of critical fluids. It ensures safety and plant integrity. It supports automation and instrumentation. It impacts productivity and operational uptime. And it is subject to thorough inspection and testing. Speaking of inspection and documentation, let's review common drawings used in piping projects. P&ID, piping and instrumentation diagram shows process flow and control logic. GIA drawing, general arrangement, shows 3D layout of piping routes. Isometric drawing, detailed spool drawing with dimensions for fabrication. Support drawing, shows placement of guides, hangers, and anchors. Finally, let's understand the major inspection and testing methods used in piping. Visual inspection, for weld quality and alignment. Hydrostatic testing, to check pressure and leakage integrity. Radiographic testing, X-ray to detect internal weld defects. Dye penetrant testing, to find surface cracks. PMI, positive material identification, to confirm the chemical composition of piping materials. So, that's the full technical overview of industrial piping systems. Understanding these basics is essential for engineers, QA/QC inspectors, and construction professionals working in oil and gas, power, chemical, and utility sectors. Please see continuation video part 2. Thank you for watching. For more real-world engineering knowledge, subscribe to Global Site Engineering.